We have just reviewed why the pandas library in Python is very useful and talked about the two main data structures in it. Let's get started with our pandas notebook to review these data structures. To follow along, please open Introduction to Pandas Notebook in your folder for week 4. If you're ready, let's now try importing the pandas module as a part of our notebook. So you'll see here in this line, it says import pandas spd. We'll run that. Now our notebook is ready to use pandas functions. But before we dive into the details of those pandas functions, let's review our two main data structures we just talked about. The first one is pandas series. Here, we create a series object called ser, I'll refer to as, which is like a NumPy array. But we can define the index labels, as you see here, together with the data. So I say ser equals pandas series, in parentheses, data equals an array, comma, index equals, and we can name our indices anything we want there. We can actually go through, and we see that all of them are names. When I run this, the ser will be created, and when we output ser, we'll see the data array indexed by those names we put in our data structure. So instead of indices being 0 through 4, we have a 5-element series with indexes defined as Tom, Bob, Nancy, etc. Although I defined the data and index using a clear format in this example, we could have skipped data and index equals. So I could have just done get rid of index and get rid of data, and the output would have been the same, because pandas knows how to resolve those two arrays into a series data structure. Another thing to recognize about the series compared to NumPy array is that the data types can be heterogeneous. So if I switch some of the data with strings, like I'll say here, maybe foo, oops, and then I'll go change another one of these to maybe bar. I'll see that those values will change. If at any point you get confused about the indices, you can display the index like we have here as ser.index, and it's going to give you the list of all the indices. We can use any of the indices by using it within rectangular brackets to access data at that location. So I'll say ser, and I'll use Nancy as the index. And when we look at our data here, the Nancy index points to value 300. So if we run this, we'll indeed get 300 as the output. Alternatively, we could have used the log function of the series object to get the value out of a location. So instead of ser in brackets Nancy, if I said log Nancy, I'm saying give me the location, the value at the location indexed by Nancy, and we see that the output would be the same. Now if we wanted to access multiple locations, we can type let's say ser, we pass it an array of Nancy and Bob as the indexes. And if we run this, it's going to give us the two data values indexed by Nancy and Bob. Another way to access data at a series location is to use the numeric indices. Here we access elements 4, 3, and 1 in SER. A reminder that like all other array indices, series indices also start by 0. So let's go ahead and run this. We'll see that locations 4 indexed by Eric, 3 indexed by Dan, and 1 indexed by Bob are displayed. We can also use the ilog function to achieve the same thing by typing, let's copy and paste this just to be clear, by typing index location 2, and it should give us the value in the second 012, second index pointed by Nancy. Next in this notebook, you see usage of an index and checking if an index exists in a series. So you can check quickly if a data value indexed by Bob exists in SER object. So I'll just say Bob in SER, and you'll see that it's going to evaluate to true because we have Bob as one of our indices in this object. We can also use Python operations on a series just like we did in NumPy. Here we multiply the whole series by 2. So let's run this. So we see that, actually let's before that copy and paste and first display series. We see the values in that. And here I'm multiplying those values by 2. If you notice something interesting related to strings, you're on the right path. When I multiply the string values to be by 2, they'll get repeated 2 times. We can also do a calculation on squares of the series data elements. Let's do that. And in this case, we'll have an error because it doesn't know how to evaluate the squares of the strings. So instead, let's get the locations, the numeric ones, Nancy and Eric, and repeat the same operation. We'll see that on the part of the series that we took out of our series object, SER object, we can calculate those squares. Next, we will talk about pandas data frames. There are many ways to create data frames. We often just read and ingest data into a data frame. But before we do that, let's create data frames manually and review some simple ways to work with those data frames. Let's start by creating a data frame out of a dictionary of series of objects. Remember, we are adding another dimension to our data structure, so we need to label each series object. So let's just go ahead and create a dictionary, right? A D equals, and in the first label 1, we have a series with some values and indices apple, ball, clock. And in the second one, we name it 2, and we have a series with 111 and some things with numbers, and indices, 4 indices associated to those. So I'll go ahead and run this. Now that we have a dictionary, we can load this data into a data frame called df. We'll type df equals pd.dataframe. In parentheses, we'll give it as an input the dictionary that we just created, and we'll just display the contents of df. So if I run this, I'll see that 2 columns for the data are generated, and the series in the dictionary are merged in the data frame. Notice that index labels are merged as well, which resulted in having indices apple, ball, cereal, clock, and Dancy as series labels, row labels in this case, and 1 and 2 as the column labels. And we see that actually the first column, the series 1 that was labeled by 1, didn't have some of those indices. Like it didn't have cereal and Dancy, like the second one does. There, those values will show up as NaN. That means not a number, to indicate there was no value for that, or that value was undefined for that index in that series. So when we say df, the output is shown in a clear tabular format. But we could have also printed df, which changes the formatting a little bit. So let's actually go ahead and say here, retype print df in that int25 line. Instead of df, I turn the second line into print df. If I run this again, I'll see that it's printed in a little bit of different way. Same tabular format, but the formatting changed. If you're again confused of these, what the column and index labels are, you can print them out by saying df index, and let's run that, and df columns. So, and it shows you also those are type object. We could have also selected some of the index numbers and columns. Right? Now we'll use some of these. Here in this line, in 36, as it points out now, if we say pd.dataframe and give dictionary as the input to it, and we only pick indices, Dancy, ball, and apple for column indexes from the series that we have in the dictionary D. So if I run this, I'll see that row labels are Dancy, ball, apple. Only a subset of the data that was in the dictionary got turned into a data frame. Now we can select the column label that doesn't exist, just like we do here. We are creating a data frame with that dictionary, just like we did in int29, and this now I'm on line int37 according to this notebook. I pick the row labels, Dancy, ball, apple, just like I did in the line above, but I'm adding new columns to it. Remember, my dictionary had 1 and 2 as columns. Instead, I'm asking, give me columns 2 and 5. When we do that, we selected the label that doesn't exist, 5. So all of the values in that column, as we see here, will show up as NaN for undefined. We can also create data frames from regular Python dictionaries rather than a set of series objects. Here we have a data array of 2 dictionaries, Alex1, Joe1 is in one, and the second one, as you see there, Emma, Dora, L is pointing out to some numeric values. We can load it into a data frame using pd.dataframe, the data frame creation function for creating an object, a data frame object, and load data directly into it. So if I run this, we'll see that Alex, Alice, Dora, Emma, Joe, the labels here got created as columns, and the row labels are 0 and 1. Because we didn't provide index labels, we will use as row indices. So it's like arrays starting with 0 and 1. They numerically get indexed. I can provide an index label array to this data frame. So if I say pd.dataframe, and I give the data, and provide index orange and red as index labels, the same data frame will be created, but instead of 0 and 1, I'll have orange and red as different row labels. Just like we did before, we can select some of the elements from the dictionary as columns to constrain the data set we work with. So here we do pd.dataframe and data, and we give the columns Joe, Dora, Alice. When we create this data frame, we will have rows again indexed by 0 and 1, and we'll have only the columns we selected from the original data set, data dictionaries. Now, how do we get data out of a data frame? And how do we use those basic data frame operations? Let's go back to our original data frame. Right? DF, if I display that, you will remember that 1 and 2 were column labels, and apple, ball, cereal, clock, dance, were row labels in that. We can use the label for columns to select a column out of the frame. So when we say DF in square brackets 1 as the index, we receive a series object in return. Indexed by, again, apple, ball. We'll have the row indices, but we'll have one of these columns displayed. Using these columns, we can actually create new columns and add or insert them to the data frame on the fly. So here I'll create a third column in my data frame DF. We'll call it DF3, and it will be the multiplication of the values in DF1 and DF2. Here we see that the third column was created. Let's run that as a set of as a function of columns 1 and 2. In the next one, we have a logical operation. I want to add another column called flag, which rather than a numerical operation like multiplication, I'll use a logical operation which results in a Boolean value being generated. And we'll use df flag and equals df1 greater than 250. It's going to give us true for the values that are greater than 250 in column 1. So when you look at it, it holds true. 100, 200 are false. NaN should be false by nature. But 300 is a number that's greater than 250, like we specified. So it's going to evaluate to true. And NaN, again, we can't compare that to any number. So it's false. So we have that fourth column there called flag. So now, how do we remove or delete data from data frames? Right? dfpop is used to return the column it's provided with its ID, and delete or drop that column from the frame. So if we say here 3, the value 3, a variable name, is the column 3 out of this df data frame, we'll see that 3 was returned, column 3 was returned as a series object. And when I display the df again, we'll see that third column is gone. So we popped it out, assigned it to a variable, and it permanently removed column 3 from our data frame. So that column is gone. We could have also used the del function to delete columns. So here we see del df, and as an index 2 is provided. If we run that and display df, we'll see that the second column indexed by 2, is gone and deleted out of our df permanently. However, in this case, we didn't get the output displayed, unlike the pop operation. This last example is interesting, as it creates a new column by selecting the first 2 rows of another column. We do here df insert, so we are inserting something into df, our data frame. And we will name that the label copy of 1. Okay? And it's going to exactly copy that 1 into that second column. So it's going to add to the end of this data frame a column that looks exactly like column 1, but its indexed, column index or label is copy of 1. Here, we are actually changing things a little bit, right? We are saying, get the first 2 values in data frame column 1 and assign it to a data frame column called 1 upper half. So when we do that and run this, we'll see that we'll have any column here with the first 2 values in column 1, and the rest of the columns, the rows in this column show up as undefined. Through the rest of this lesson, we'll be using a movie dataset analysis as a case study. In the upcoming videos, we will provide you with some examples of using the pandas for data ingestion, generating descriptive statistics on data, data cleaning, subsetting, filtering, insertion, deletion, and aggregation, as well as introduce you to the basics of working with timestamps.